Hi everyone, I'm Tem Amunat Chianpatanodom, and today I'll be talking about the impacts of rising sea levels on California. This is a graph I saw recently and it made me think about this topic. The global sea level rise is one of the many issues that will impact everyone in every country, including the United States. But still, a lot of people view it as insignificant because it hasn't caused any major problems yet. The objective of this presentation is to convince you guys that the global sea level rise is an important problem and that it should not be overlooked. This project also aims to persuade people to be proactive and to establish preventative measures in California before it's too late. As you can see from this graph, studies show that there will be a 1.2 meter sea level rise by the year 2100. So my hypothesis is, will the global sea level rise significantly impact California? First of all, why California? I chose to focus my project on the United States because there's a lot of data available. And I chose California because of two reasons. Firstly, it is the most populated state. Secondly, it is near the Pacific Ocean, which means that it will be more vulnerable to the sea level rise than other states. I would like to mention that the projection system of all maps in this presentation is in the UTM Zone 11N coordinate system, which is why the compass is tilted. Okay, so back to proving my hypothesis. There are two factors that will determine whether or not my hypothesis is correct, and they are elevation and population. This is a raster map of the elevation of California. As you can see, the coastline is green, which means that the elevation there is low. This supports my hypothesis that the global sea level rise will impact California significantly. Low elevations means that it is easy for the global sea level to overcome the coastline elevation. The second factor is population, and this disproves my hypothesis. The counties near the coastline have low populations, except for the lower parts of California. This map disproves my hypothesis because if the population near the coast is low, then if parts of California coast were to flood, it would not cause a significant impact on the state. However, this information is wrong. Wait, it's not wrong. It's just misleading. My second approach was to search for a raster map of the California population because raster maps are more precise. But through hours of searching, I couldn't find any, so I had to change my approach. I found data on the population of California per square mile. And although the data is not as accurate as a raster map, at least it is accurate enough to give a general sense of the population density, which supports my hypothesis. High population in the coastline means that a lot of people are going to be affected by the sea level rise. So to answer my hypothesis, yes, the sea level rise will significantly impact California, but my second question is how? How will it impact California? Obviously, it's going to change the size of California. Parts of the California coastline will be flooded. This kind of disproves my hypothesis a bit because the maps aren't that different because it's difficult to see the flooded areas. But because these places are highly populated, the small loss of land still affects a lot of people. Oh, and this is when I encountered my first obstacle. My first attempt to generate this year 2100 California map was to manipulate the elevation raster map. But the raster map was really hard to modify. I wasn't able to edit anything except for the colors and the labels. So I had to find a different shapefile elevation map, and I created the 2100 map by exporting data with an elevation of 1.2 meters or lower. Another impact of the sea level rise is the destruction of buildings and houses. But for this project, I will only be covering the impacts on schools and hospitals. The reason I chose these two is that they have a direct impact with the people. Without schools, there will be no education, and without hospitals, people will not have access to healthcare. Another reason is that data on buildings and on people's houses are really hard to find. So these are the schools that will be flooded by the year 2100, and these are the hospitals that will be flooded. As you can see, all of them are on the coastline. One of my aims is to persuade people to be proactive and to establish preventative measures in California. So I have included the replacement costs for the destroyed schools and hospitals. The average amount of money needed to educate one student is around $10,000. So I calculated the replacement cost by multiplying this number with the number of students in each school, which is shown here in the map. The larger the circle is, the more expensive it is to replace because there are more students there. Most of the destroyed schools are clustered together, so it's a bit hard to see clearly. I'll be zooming in into each of these areas, This is the first one, and this is the second one. Realistically, the rise in sea levels would also flood the areas near San Pablo and San Francisco Bay, and not just the California coastline. But this map was generated by using data from Esri, which was probably not accurate. So for this area, I had to manually select the schools by eyeballing the shade of color they were in, and this is the third area. Similarly, for hospitals, I searched for the average cost for building each type of hospital. For this map, I had to join an Excel data to a shapefile because the metadata of the hospital data I downloaded did not have enough information. The metadata contained only the names and the location of the hospitals, so I had to Google each hospital and search for their type of hospital. I also had to search for the average cost to build each type of hospital. As you can see in this map, it has 4 relevant layers. The first layer shows the types of hospitals, which is represented by using different colors. The second layer is the size of the points, which represents different replacement costs. The larger the circle is, the more expensive it is to replace. The third layer is the flooded areas, which is the layer that is quite difficult to see. The fourth layer shows the affected counties, which is represented by the orange color. I will also be zooming in into each areas because all of the points are clustered together. This is the first area, and this is the second area. The total replacement cost is roughly around $800 million, and bear in mind that this only accounts for the destroyed hospitals and schools. In reality, the sea level rise would also destroy houses, buildings, police stations, water pipes, and a lot more. If I had the time and the expertise, I would like to create a map that also shows the flooded areas near the San Pablo and San Francisco Bay. If possible, I would also like to use only governmental data from your project because it is more reliable than data from crowdsourcing. Ideally, I would like to have data on all of the houses and buildings in the flooded area so that I can accurately calculate the total replacement cost. I would also like to have more details in the data for hospitals and schools. My calculated total replacement cost is very unreliable, but at least it gives you a sense of how big the impact of sea level rise will be on California. In an ideal situation, I would have data on the cost to create each school and each hospital. With more advanced spatial analysis, I would be able to identify the risk percentage of the buildings near the flooded areas because the high and low tides also play a role. Buildings in the non-flooded areas but near the flooded areas could use this advanced information to help them decide whether or not they should move. If you have any questions, this is my email. Thank you for listening.